Hello everyone, myself Shweta. I welcome you all to the industry webinar series of summer internship program powered by Comedkares Innovation Hub. So we are here. This webinar is about how to design electronic prototypes using combination of hardware and software design. So we have Mr. Veeru Shivanagaudar with us. He is an electronics and communication engineering graduate from KHK Institute of Technology. Mr. Veeru is an experienced business development manager with a demonstrated history of working in the semiconductors industry, skilled in customer relationship, direct sales, product marketing, and leadership. He is Chief of Business Development in Cilium Devices Private Limited. Cilium Devices Private Limited is a startup with the wireless innovation aims to improve how humans interact with the world and how machines converse with each other. Mr. Veeru is also a co-founder and director of Ninira Technologies Private Limited. Mr. Veeru has worked before as a diploma trainee engineer for Star Engineers Private Limited in the beginning of his career, then moved to Aesthetic Stencils Private Limited as a regional marketing engineer for 3 years, then joined Global Marketing Services India as technical sales engineer. Mr. Veeru has also worked in Deshpande startups as a business development manager, and with a vast experience in semiconductor field, he started his own venture. So, welcome, Mr. Veeru Shivanagowda.
Thank you, ma. So I think all the crowd are here now. I think a lot of innovations are there, right? Once again, good evening, team. So as mentioned, my name is Veeru. So I'm based out in Hubli, and carrying more than 12 years of experience in the same industry, electronics industry. I think it's a good thing. I think we had connected in this platform. Yeah, thanks to Comedkares, right? So particularly they are doing a lot of things to give you the innovation stuff and the information about these prototyping and how to convert this idea to prototype. In my career, I think I had worked many such companies, right, where innovations came into the pictures of where we had involved in a lot of stuff. Today we are going to learn how this electronics prototype can be built, so from starting idea to prototype, how we can start the journey between. I think I had understand from Pawan that you guys are all the stage where you had already identified the ideas and evaluated the ideas now. So now next step is how to convert that idea into the prototype. That is where I think your guys are all standing. Am I right? Can anyone, please unmute and tell us, yeah, great. So I think, so let's start with, just would like to share you some presentation here. Please confirm whether my screen is visible for you guys. So yeah, to start with, uh, just would like to, go with this flow. So in this presentation, so what are the electronics prototypes, how it's going to be start with, and what are the different prototype stages. Next to that, we have to include a lot of stuff in this prototype stages, and process of electronics slash hardware prototype. So basically we call electronics hardware rather than hardware product, or how the hardware prototype. And we have a different types of prototype testing, how to do that testing, in a various manner. And I would like to take as well case studies as well in this whole presentation. Just meanwhile, can you, one guy, one or two guys, can you unmute and can you please share with me some ideas, which area or which segment you are working on, or already identify the ideas, so that it will be so more interactive session. So rather than going with the PPT, just would like to have some interactions between the audience as well. Am I audible?
Yes, sir. Audible.
Yeah. Please go ahead.
Yeah, any of the students, can you just brief about the problem statement you have received and what's the status? I mean, what you guys are working on?
Hello, sir. So the interns are working on the problem of solid waste management. They have identified few of the problems, but not yet gone to the ideation phase. So the few of the problems which they identified are like there is problem in segregation of waste, since mixed waste is coming into the place of segregation, and even the packaging of if you consider any online food services like Zomato, Swiggy, if plastic waste is containing food items in it, it cannot be recycled. So such problems they have identified right now, mainly in the segregation field, and they're working on. They have not come up with ideas; they have just identified the problems. Right?
Oh, great. I think certain validation has to be required for identifying ideas. It's good, I think. Thanks to you. And in fact, I need some case studies to explain with you along with the PPT. That's the reason I'm asking you guys. No issues. Like we'll start with. Is it be okay?
Yes, sir. Sure.
Yeah, sure. So yeah, as I mentioned, idea to prototype. So there are some stages are there. First what we'll do basically. So we'll identify the ideas. So where this idea constraint understanding. So how we do this idea and identification. So first we will identify the problem identification, where exactly the problem is about, and we'll do sit along with my team members, and I will do the brainstorming on that and understood whether it is really problem is there or not, because some validation is, as I mentioned, some validation is required initial stage itself, right? So once we have the problem in hand and we identified, yes, we have to work towards this, then we have to think about architecture designing in terms of like I want to use some similar like language, because it will be helpful for you to understand. See, the product has to be like feel free, like the user can easily use that product. It's not more like, it should not be like complex product and all stuff. So initially we have to sit and discuss about the system architect design, like feasibility study in terms of technology, like whether we are adopting the technology, whether it's feasible to do or not. That's the first stage, right? And certain prototypes should have a timelines, because see, I had seen some cases, right? So some startups or some companies working on years together to to close that prototype stage itself. Initially, first and foremost important is to feasibility study in terms of technology, whether it is workable or not, then time and cost, so whether it will fall under my budget or not. Then we have to start with a POC, right? So then the industrial design will come into the picture, like how user can feel this product actually. So how we can what user prefers actually. So some example, like user point of view, they will seeking some product, like different size and angle. So we should understand the user point of view. We have to be in user place and think about how this prototype should be, how this problem, like how this product will solve their problem. And see, if you can see this example, like how will the user hold this device, what style in best suited for users, how resistant it is, like it should be like workable, right? And it also work in a different environmental conditions, whether we need to think this all the aspects in before itself. So majority all startups or companies, they will fail into this actually. Directly they will dump into this hardware design prototyping. It's not a stage, because we have to go across this all these three stages, then only the hardware prototyping, that's called the electronics prototyping. Electronics and hardware design are both are the same. First what we'll do in a hardware designing actually, so we will sit and discuss. So now the stage where we had understood the customer point of view, user point of view, how this product should be and what will be the size and all, right? So then exactly we have to work on the hardware part now. So the thing is, first and foremost, block diagram. It's a common one, like in all aspects block diagram is very essential, right? I will explain you how the block diagrams looks like in the next slides, right? And what all the parameters we need to consider in the block diagrams, schematics, layouts. So it's all like generic, the idea to prototype stage, where you have to consider this all the aspects into this. And then schematic layout will be there, and Gerber generation, bomb selection. I will explain you in this session. So what is this all content about? What is the bomb? What is the Gerber generation? What is the schematic? What is the block diagram? This all the stuff we are going to discuss in that. Electronics prototype is like nothing like, it's combination of software plus hardware. It's not only work for like, completely hardware. It's not called a electronics prototype. Software, it should be there. Software we should include in that actually, in terms of firmware development, in terms of like, some special stacks will be there, like to code the microcontrollers and all, right? And some after this product, right? So once we are ready with the product, then the application point of view, is there a kind of interfacing application point of view also is required. That's called the cloud based application development. That's also very essential. Then the mechanical aspects will come into the picture. Any electronics prototype or any electronics product, it has to be set in the mechanical casings. It's the combination of hardware plus software plus mechanical. It's called a complete prototype, right? So now today we are discussing only focusing on the electronics prototype, right? So is there any questions or any doubts in this slide? Please stop me and ask me the questions, because I need a more interactive session on this, right? uh, and also please let me know whether I'm going too fast and too slow. Please let me know. I will take a like a half-minute break now to get some audience like answers from your side.
Okay. You can go ahead, sir.
Sorry, please come back.
It's okay, sir. We can listen.
Okay, great. So then I think we should go for next slide. The process, how the electronic prototype process will happen now. So what we had discussed, what I had understood from Pawan, so now you had identified, understood the needs of constraints, like you already identify the ideas. And I think some people are like in the stage of brainstorming sessions, like, we have to sit with like, team members and we have to design the concepts and all stuff. I think guys, you are there in this stage. And now, so then the next process will be product concept design, practically exploring the fundamental elements like functionality, feasibility, and terms of technology. As I said in the last slide, so whether my technology is adaptable for the user or not, or is it feasibly or not, the technology can be build it in a lesser time or lesser cost. So that stage will come into this second stage. And any prototypes, we have to build a minimum 2 to 3 concepts. So what is the concept actually? Can anyone tell us what is a prototype concept?
Versions of prototypes.
Exactly. So the thing is, the prototypes, how my prototypes will work actually, how I should design it and how should I operate it, kind of concepts we have to design it. See, for example, I will take one example, like now for civil department, or kind of like, they will do some architecture actually. So they will design it, first design, second design, third design. As like in electronics prototype, you have to think about user point of view, or and the technology feasibility point of view, and the cost and time point of view. We have to develop the concept, at least like 2 to 3 concept. We have to do with a team, whether we will understand that each one of viewpoint will be different, so that then finally we have to conclude on the one concept. You have to go ahead for a product concept development. That is the third stage. Product concept development is like nothing like, preparing the innovation idea. Now the concept is ready. Now the idea has to be like, how innovatively we can do that. For example, now I would like to take an example of mm, okay, the same product can be built it in different 2 to 3 concepts, right? For example, for an example of toys, for example, like electronic toys, you can take it. See, toys can be fulfill the user, like, babies can work with the toys and all. So now the electronics, Wi-Fi, Bluetooth toys is also coming in. It's smart devices, like there is a innovation of Wi-Fi and Bluetooth that is adopting now. This kind of innovation idea has to be included in the product concept development stage itself. So and second point is like focusing on all the concept development efforts in terms of engineering, architecture, finalization, circuit schematics, and BOM selections. Uh, these all the aspects we have to consider, and we have to take a final decision on that to take to the next level for design, prototyping, and construction. Once you have decided, right, you can't go and come back to this stage. Why? Because you will lose the time there, you will lose the money there. Whatever you want to start with, or the efforts whatever you are putting in this three stages, right, it has to be full and final and get clarity before starting any prototype, right? Now the stage where we are into the design, prototyping, and construction, right? So in terms of like, we will use some softwares in the electronics. I will run through in the next slide. I will explain you the some different softwares are there for electronics prototyping, where you can use that and build your first level design. Even though in the software itself, like, you can do the testing as well, whether my like design is workable or not, kind of thing. And so this stage, it will helpful for us to identify the improvements. Is there any kind of the improvements or further development can be added, or further innovations can be added? But it's not a major involvement which should be there. But the thing is, whatever that you had taken this three stage, that is the final one. The fourth stage, whether we have some certain improvements we need to include in that based on the user experience. We have to talk to the customer. Yes, this is a stage where we are into. Is there any kind of like, the thing is where the innovation, one or more innovations can be added. This kind of improvements can be done it here. And now the fourth stage is like a prototype development, identifying the changes during the assembly. This stage will be completely in the point of view, like in the assembly point of view. Now the stage where we are reached the prototype development stage. Now the design is ready. Now we are going to start with the prototype development stage now. Any questions on this slide, please?
Yes, sir. Yes, sir. Sir, can you
Yeah, please
explain
go ahead.
what is the BOM section?
Okay, can I run through that all the this in the next slide? Is it be okay for you, or else I will tell you now itself, because you will get some confusion on that. So I want to take the BOM selection is like, the bill of material. It's content of all the variants of components in one sheet. I will explain you that in the next slide.
I have a doubt.
Yeah, please go ahead.
So when you generally designing a prototype, will you use a original, means the electronic products?
Electronics components. It's not a
Yeah.
product.
Means
Once
will
a
you?
product.
Yes.
Of course. Because see, the thing is now here we will use electronics components, not a product. Okay, that is the next slide. I
Yeah,
will show
sir.
you that. The components, yes, we do use the original components itself. Like, so that is a
Means
stage.
will it work? That means the prototype, will it work?
There is some process are there actually. The initial process, middle level process, and the last level of prototype development. The certain level of processes, certain components are there actually. For a prototype, different components are there, but it will work.
Okay, sir. Thank you, sir.
Yeah. There are like, this is standard what industry use the product design phase. Okay. The where we like will usually, this is a template for us, this is a guru for us, like, to start with, like idea to prototype. These all the stages we have to go with, right? As I mentioned, like, system architecture design, so what will be its content about, and the industrial design, it's a repeat like last slide. This is for generic, just I will share you the details and all. Usually all the companies, all the startups will use these templates for to build the prototypes. It's a combination of the hardware design, hardware prototyping, next software development is there, software mechanical engineering, then certifications. This all together, all the phases will be there. Total 10 phases are there once the from starting from idea to prototype. Yeah. So now the prototype stages where we had are discussing now, focusing on the electronics itself. Like as I mentioned earlier, the first you should start with a block diagram. This is how looks like a block diagram. So in the particularly any product, right, the microcontroller or microprocessors are a main brain of the electronics prototype or product, where we need other peripherals, like I need a Bluetooth Wi-Fi connectivity, I need a temperature sensor, I need an accelerometer, I need a display, I need a GPS. These are all the basic element we can include in that. uh, Including this all together, I would like to take one example here. For example, I want to track my vehicle, exactly where is my vehicle, and I need to get that data in my mobile. Okay. Now that device has to be fit in the vehicle. Okay. And it should be battery operated, because sometimes vehicle stop, engine fails, we can't generate the power from so now the basic element, the microcontroller, we need to choose that, we need to select application. That is very basic phenomenal, we need to understand that microcontroller or microprocessor, based on your application, the plenty of microcontrollers are available in the market, right? So along with that, also what I will do, I will sit with my team and I understood, yes, I need to track my vehicle, what is a major factor I need to include. The second stage is the GPS. Yes, so along with the GPS, exactly I will track my vehicle where it is. GPS will give the data, it will access the data and it will reverse to the controller, it will give the data to the microcontroller. And then I need a Bluetooth and Wi-Fi, because I need to connect with my mobile. That's the reason Bluetooth I'm using here. And also battery backup should be there, at least 3 hours battery backup should be there. So that's the reason I'm using a lithium ion battery here. And also battery charger is required, uh, and also the temperature, because the models can be like, because engine side there is a lot of temperature and a lot of like humidity will be there, so I need to sense that temperature, how much it is. So based on that, microcontroller can act, so whether it can reduce this performance or it can be like break sometime kind of. This all the elements we can consider in the design itself, like in a block diagram. First stage, that is a system block diagram we call typically, like in an industry. And micro USB connector is also there, because I need to connect my mobile over there. And most important thing is display. I need to see the the temperature, I need to see the vehicle, the fuel and all stuff we can monitor in the display itself. So then this is a block diagram. Now the next stage will be the selection of the components. So I think one of you, I think you had asked the question, right, whether we are using the original components. Yes, of course, these are all the components we can access in initial itself. uh, so for a microcontroller we can use this IC, right? And the temperature sensor, which like we need to research a lot on the initial stage itself, whether which component I need to use it, right? So selection of the components is a very essential, because once you had selected, you need to design the PCB along with the component footprint, component leads. These all the aspects we need to consider it. Guys, am I going very fast, or how it is like? Is it like conveyable for you?
Yes, sir.
Yes, sir.
Yeah.
Yes. Yeah.
Great, great, great. Thank you. Now the thing is like, see, for example, some components having a 3 terminals. This is 3 legs are there. Some components having a 2 legs are there. So it's a very essential. Like we should understand initially itself on the component side, which component we are using. Some components are coming in. LEDs are not there. Only the small LEDs. It will fit. It will sit on the only PCB. There is no through hole components and kind of. So shall we go for next slide now?
Sir, one more
Yeah.
doubt, sir.
Yeah, please.
Uh, a few minute time ago, you told I want to track my bike from
Huh.
anywhere.
Okay.
So how it works, sir? This one.
GPS is there, right? So GPS model is there. So GPS, wherever you go, right, it will access your data. It should be connected with your mobile.
Sir,
I think
without
in your,
internet, how to do, sir?
sorry, please come back.
Without internet, how to do?
No, it should be connected with your mobile. That's the reason we are using a Bluetooth here, Bluetooth and Wi-Fi.
If your bike is like 2 kilometer and 3 kilometer distance, so how to track?
Uh, the thing is, yes, absolutely, there should be transmitter and receiver end. For example, take an example of in a bike, you have a transmitter plus receiver model is there. This is inbuilt in the microcontroller using a Bluetooth and Wi-Fi. And you want to access that data in your home, right? You have a cloud system there. That's the reason software will come into the picture. Whatever the data is generating from microcontroller, it will give the data to the cloud. Either we can use a GPS or a Bluetooth and Wi-Fi model. Through Bluetooth and Wi-Fi or through GPS, it will convert that data to the cloud services, cloud platform, where you can see the exactly where is my vehicle and all. There should be hardware plus software including this electronics prototype. I hope like you got a clearance on this.
Sir, one more doubt. Programming
Yeah.
connector.
Yeah.
One doubt. Programming connector. I don't know. Can you explain, sir?
Sorry. Which one?
Programming connector.
Program. Okay, so there is a some special, sort of, connectors where we can use it. It will work based on the, the elements where it can switch, kind of relays. It's best example of relays, whatever, the thing is like once I need, sorry, just I'm having some background noise here. Yeah, so particularly the program connector will be like used for, particularly some cases like, I want to access the data now, present, I want to cut off that data. That's kind of like synergy where we can use the programming connector. So yes, now we had completed the stage one, step one. Now the thing is like, now we are into the steps two. So estimate the production cost. So now you had like selected the components all together. You need to this is a part number. You need to select this part number, and you need to estimate the production cost. So production cost is including like, in terms of PCB, bare PCB price, design cost, and the components price. These all aspects will come into the picture, the production cost itself. Then the third step will be the design and schematic diagram. So I think you had guys who had worked on a schematic level, because where it will computerized design, where we can connect one component to another component, and we can test it as well. So you can use this all the softwares. Deep Trans is there, and especially KiCad and Eagle. Oh, sorry, spell mistake. Eagle, especially it will like freelancing softwares. You can access that certain level, and then they will charge you. The mental graphics is there and cadence is there. So these all the software will help you to build the schematic designs and simulate that. So what is a schematic design? Schematic design is a where computerized design, where we can connect one component to another component and we can test it out. And fourth stage will be the design and the printed circuit boards. Yes, this is a like where we are going to connect with these all the one component to another component. We are using the like PCB design, where we are connecting the dot between one component to another component using the tracks. There is some standards are there. IPC is 6021. The specific IPC standard will say how to design my PCB, and what will be my track width and what will be my trace width. These all aspects we need to consider while designing the PCB itself. And the bill of material. Yes, bill of material is a kind of this all together. What is the content of bill of material? For example, this bill of material content about this value, component value, and the part number. Yes, and the footprint. For example, R1, footprint. For example, like L2, C16, C15. It will give the complete data where the PCB is having the components and PCB. It's called a bill of material. It's a bill of material, a generic word. It will also work for a mechanical as well as electronics. It's a standard generic word because the mechanical aspects, yes, I need a screw, I need a kind of spanner, kind of all the details has to be there. Whatever you are going to procure to build the prototype, that is called a bill of material. And first, ordering the PCB prototypes. Yes, if you are looking for, if you have any in small setup where you can do also the PCB fabrication in-house as well, then I think we can order some few prototypes and evaluate program and debug the repeat actually. So evaluation stage where you have to simulate. So that's what evaluation means, simulate. So you need to test your design before going for printing itself. So you need to test it, design aspects. Once you got the bare PCB prototypes, you need to assemble this all the components. You need to mount that components in this PCB, then you need to test it out, right? Before this, there will be one stage where you can use a breadboard. The breadboard is series dotted connected. It will connect internally. It will connect to all the breadboard kind of things, where we can easily mount this all the components by hand. There is no soldering is required, and there is no wire is the wire is required one-to-one connectivity. So then you can do the testing as well. This is a second stage where you can do the PCB prototyping and all. So guys, I think I'm too fast. So let me have a, let me answer you questions. Do you have any questions now? Am I audible, guys?
Yes, sir, yes.
Okay. So yes, for example, I want to take one example, here. Uh, I want to build one oxygen concentrator because I want to take this case study here itself. So what is the basic elements is required first?
Sensor.
Yes. Which sensor?
Can you repeat the question again?
Just I would like to build the oxygen concentrator. Now I have one idea now. I want to build my own oxygen concentrator, which can help to this all the patients. It's a tabletop oxygen concentrator. So now, can anyone help me out to how to start with, and what all the aspects we need to consider in that? Just
Sir,
generically we can discuss on that. Yeah.
First you choose Arduino, sir.
Okay.
Arduino and sensor, which detect. I don't know names, sir, but
No issues. Uh, Arduino is one of the microcontroller, right?
yeah.
So what it will do, so it will collect the all the information, and we have to code that such a way that based on the applications we have to code that Arduino, so it will work on that. It's a very basic level. So now I would like to take a case study of oxygen concentrator where I need a the pressure monitor. One device is required in that, and display is required in that. Just will apply the stages here. I need a display here. Again, it should be work on the battery level, and the temperature sensor should be is also required in that. And yes, is there just before starting the oxygen concentrator, whether it is a smart or normal oxygen concentrator. If it is smart, yes, we need to use a Bluetooth and Wi-Fi in that. Yes, so now we had designed the block diagram. Now I need to select the components now for that. So which Bluetooth model, which microcontroller, which connectivity, how much battery should be there. These all the aspects we need to consider, right? Yes. So now I would like to take this here. Yes. Now the where stage we are into now, the computer simulation. So now we had selected the components, we had ordered the PCBs, we had assembled the components. Now we have to test it in a different aspects. So first thing is we will first and foremost process is we will do this simulation here. We'll do the schematic design and we'll do the simulation is nothing like there will be some waveform generations will be there, and so we need to see we can easily connect this in the software itself, and it will give the waveforms. This is called a computer simulations, and it will also give the designed data output. What will be my input and what will be my output, kind of this. Next, this all the like once it succeed, right? So once the design, the software simulation is done, we have to do the breadboard testing itself. So as I mentioned earlier, breadboard is nothing like, we have to mount this all the components in the holes, and we need to connect this one component to another component, and we have to give the power on. And there is a power supply required for this, 5 volt or 30 volt kind of. Maximum we can go for 30 volt. So based on your functionality, based on your applications, we can choose the power rating. For example, like 5 volt, I want to give the inputs to this. I will do simply connect the power supply, and I will see the performance of my components, all the components, whether my all the selected components is working fine or not. Then the third testing stage will be, yes, we are using on the dotted PCB. We are mounting that components and we are soldering that one to one component, and we are seeing that, whether my board is like working fine or not, kind of testing we can do that. These all the testing stages are there, right? uh, Guys, do you have any questions on this?
No, sir.
Okay, please make a note on this software side, because it's very important for you guys, I think,
Yes, sir.
coming
We did,
days.
sir.
Yeah, so KiCad is like very oftenly you can use it. Eagle software is there, right? Yes, so this was like an oxygen concentrator where we had built it in-house itself. Now we had started with the breadboard initially. Then we had mounted this all the components on the PCBs. This is the prototype PCBs. Now what we had got it, and we had tested in different aspects. And this is a child board, and this is a motherboard. Motherboard is having the microcontroller in that. Then we had fitted in this all the concentrator, like casings and all stuff. Sorry, before that, I think we had coded this all the program in these PCBs. Then we had mounted into the mechanical aspects. Now the oxygen concentrator is ready for use. Right. This is how it looks like, complete prototype journey, where the electronics prototyping, it will start from idea to prototype completely. This is not a full final product, so this is like, where we can see this is a first prototype. You can see that. Guys, do you have any questions on the slides? Please let me know so that I can, we have chill time, another 15 minutes is there. So whatever you have a questions, please let me know. I'm happy to address it for.
Yeah, sir. I have one question.
Yeah, please go ahead.
Okay. So once we are building the first prototype, that is maybe using breadboard, we are just having checking our proof of concept. That time we'll be using these sensors which are huge, but when we are going for maybe building a PCB board, which is installed in a device, so the component size reduces, right? So does the specifications of both components remain same, or do we change during that time?
See, for particularly microcontroller, right? So you can't change that. The whatever you are using the microcontroller size, there are some options are there actually in the industry, specifically electronics industry. There are two types of components. One is like through hole components. Another one is SMD components. SMD components means surface mount devices. Please make a note on this. Just after this webinar, I just would like to give some assignment on this. The surface mount devices will be used for to reduce the size of the PCB. So yes, there are some alternates components in the same value. For example, 0.1 microfarad, 1000 volt. I want to reduce this component size. Yes, there is a availability of the components in the market in 0.4 into 0.2 mm. I'm talking about. It's very, very, very minute component. So yes, 0.04, you can imagine 0.4 mm into 0.2 mm. That's called the O4 components in the SMD I'm talking about. There are several options are there. Yes, in the breadboard itself, we can use this all the components. There is no doubt in that. But once you are coming to the PCB level, right? Yes, certainly you have to use the SMD components, because now all the industries are going towards SMD. all industries or all PCBs are going to reduce their PCB because of size constraint. Yep, hope I had answered your question.
Yes, sir. Thank you.
Yeah. And guys, please make a note on the assignment or homework for you guys. Please make a note. Just would like to have details from your side. List of electronics components. Just go through that uh, in the through hole components as well as SMD components. This is very basic elements for you guys. Just you can do some homework on this.
Yes, sir.
Guys, do you have any other questions? Please let me know so that we can.
Sir, I have a doubt.
Yeah, please.
So when you're preparing a prototype,
Hmm.
whether you're using a circuit boards or a breadboard like things.
See, that's what I have mentioned here. Like very essential for you guys, especially in a college project or kind of a startup point of view. It's very essential for us to use a breadboard because we can do a lot of mistakes in that, but not in the PCB side. Once it's get printed, we can't reuse that PCB. There is a cost involved in that PCB.
Yes.
Breadboard, we can do multiple aspects. We can remove the wire, we can add it, we can add the different component in that. That possibilities, yes, we have to use a breadboard. That's very essential. Once you reach the level, you will become an expert. Then for you, I think there is no required for a breadboard. So all you will do it in a software.
Sir, your voice is break, sir.
This all the softwares you can easily
Yes,
print
sir.
the
Your voice is
designs and all.
breaking.
Yes, guys, I need a more questions.
Yeah,
Hope
guys.
this had given you some. Yes, this session had given you some information about electronics prototype, how it will work. If it's not clear, we have a time. Still, we can extend the time as well. Just I need some interactive sessions on this.
Yeah, guys, if you have any questions, please let us know.
And also, first and foremost, just would like to, as I mentioned in the presentation itself, the first two stages where you guys, yeah, the electronics product development depends on various factors. As I discussed earlier, the complexity of the product, how this new to the world, and where exactly it will be used, and where you want to design done. Actually, these all the aspects we need to consider. Whether it will be used for medical, or automotive products, or agri tech, or IoT. Based on the applications, we can choose the components. We can do the lot of design stuff. There are several standards are there in the industry where we need to follow that standards to design the medical PCBs, automotive PCBs, agri-tech PCBs, IoT PCBs. It's all having each individual having some certain standards. What is that standards actually? So there is a called IPC standards. Just you can Google it. You can reach out to that. IPC is such a guideline where we can follow this all the design aspects, right? And the first stages are very essential because without skipping this, having the skipping this, so we can't go for design and hardware prototyping.
Yes, we had one question like, how can we know a shelf life of a product when considering electronics products? So how can we decide on the shelf life? And I think knowing about the user as well as about the person who does maintenance of those things also plays a crucial role. So how can
Okay.
we know about those aspects?
So in the components, there are some batch codes actually. So batch code means when it's got manufactured, and when it's going to be like how much extent we can use it for. Typically, all the components if we kept in such a good condition or a good environment, uh, around say we can use it like 2 years down the line without assembly. I'm talking about. Um yes, after 2 years, once we are started using this component, there are some indications from the component side. It will not get solder, kind of rust on the components, kind kind of like it will not give a desired desired output. Kind of deviations will be there. Certainly in the manufacturing or any design aspects, we should see the first and foremost the batch code when it is manufactured and when it was manufactured. So there is a standard before if it is in good conditions before 2 years we should you consume that components in the PCB, not more than that. But for this all the components there is some standard temperature is required, that is 17 degrees Celsius in the room temperature I'm talking about. In the 17 degrees Celsius this all the components should be operated. But you guys initially prototype, don't worry about that, because these all the passive, these are called the passive components. It's all the passive having a good shelf life. uh, but only thing the environmental difference, how where you are exactly using, that is a major factor. And generally just would like to repeat this all the session in one sentence. Whatever you are trying to build the electronics product prototype, right? First and foremost, the what I said, the block diagram is very important. Before that, just user point of view can address it, but first and foremost block diagram is very important. You can't miss this. And then the selection of the components, it's very essential for you guys. And this all the components can be used in your breadboard. You can prepare whatever you want to play with that breadboard, you can do that. Then once you have the confidence on the breadboard, then you can shift to this PCB design. Once the PCB is designed, you have to do a lot of irritation cycle, sorry, a lot of repeatability in this, in terms of you know one prototype, two prototype, batch productions, mass production. This is stage where you are. Yes guys, do you have any other questions, please?
Yeah, students, do you have any questions?
Yes, I think we're good to go with.
Yeah, we had a wonderful session, and thank you for sharing your insights about the subject, Mr. Velu.
Yeah, it's most welcome, ma'am. Actually, you are doing a great job. Feature any support, kind of any support, like the startup or students looking for this kind of prototype support. So I'm always there for you guys.
And thank you everyone for being a wonderful audience.
Yeah.
Okay, so students might not come up with the question right now. They might be thinking about a lot of concepts. So if they are having any further questions, we would like to reach out to you and mail those questions to you so that you can clarify their doubts when they're working.
Sure, and also
projects mainly.
Yeah, and also I think it's a very beginning stage where I had dumped a lot of things into that actually, because what industry looks like, what industry, how it's work. I had given overview picture about that, but how students are, especially working on the Arduino, it's not a big deal actually. So the main objective of a prototype or a project building, right? Not work with the Arduino. First start with the Arduino, but try to convert that Arduino functionality in your real microcontroller. That is the biggest, where we can achieve a electronics prototype. That should be done.
Sir, can you
Yeah,
tell
guys.
me more information about Arduino, sir?
Arduino, it's again we have to take again one more session on that, because Arduino is very basic essential. The thing is where we can easily incorporate our applications into that. We can add a multiple features in that, and the Arduino is such a way that you can use that, and also easily the codes are available, and we can write it on. Um, and it's the kind of mini computer or mini microcontroller. It's readily available for us to use in a different applications. uh, but sure, I will arrange one more session on the Arduino, how to use that and how to code that, and particularly how to in exactly what applications we can use the Arduino, what will be the next Arduino. So that I think definitely I can take into the next session. Definitely I can do that.
We would really like to have a session from you, sir, next time. It was really a wonderful session. So thank you so much once again. Thank you,
Thank you.
everyone.
Thank you.